Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. Now take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Missing Information by Sotir, and here are the rules. Sudoku, normal Sudoku rules apply. Place the digits 1 through 9 once in every row, column, and 3x3 box. Killer cages. Digits in a cage do not repeat, and all cages sum to the same total. And basically, the digits in a cage sum to a certain total, and that's the sum of the cage. And all cages sum to the same total. So that's a very important rule there. This is not part of the typical killer cage rule set. And the missing information here is the number in the top left corner of a cage, which we normally have. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so we know all cages sum to the same total. The minimum value for a cage, then, is 5, because we have 5 in the largest cage. So therefore, its minimum is 1 plus 2 plus 3 plus 4 plus 5, which is 15 at minimum. The maximum amount is, what's the maximum amount of two digits? And we know this is specifically, then, 15 to 17. So 17 is the max, 15 is the minimum. Because the maximum would be 8 plus 9, which would be 17. Now, this cage multiplied by 5, right? This is 1 cage, 2 cage, 3 cage, 4 cage, and 5 cages. So 5 times whatever the number is, minus one digit, plus another digit, has to add up to 90. Well, if you take 15 and you multiply it by 5, that gives you 75. But 75 plus a digit is never going to be 90, because that's the difference of 15. Same if you take 16. 16 times 5 is 80. 80 plus a single digit is never going to add up to 90. Therefore, we know this specifically has to be 17. So this is 8 and 9. Any of the 2-digit numbers have to be 8 and 9. So this is 8 and 9. This is 8 and 9. And these add up to, what is it? Okay, so 5 times 17 is 85. 90 minus 85 is 5. So this is a 5 here. Let's see. Any 5 digits have to be 1 through 7. And we know 1, 2, and 3 have to be in that because the only choices for 5 digits to add up to 17 is 1, 2, 3, 4, 5, 1, 2, 3, 4, 7, and 1, 2, 3, 5, 6. Those are the only sets of 5 unique digits that ever add up to 17. So the rest of column 1 has to be, this has to be 8 and 9. Well, we have an 8, 9, 8, 9 pair in box 1, which eliminates 8 and 9 from the rest of the box. So these can't be 8 and 9. Whereas the last 8 and 9, it has to be here. So this is an 8 and 9. The rest of this box must, the rest of column 1 has to be 4, 7, or 5, 6. We're not sure which. But this can't be 5, so therefore this can't be 6. Because remember, this has to add up to 11, because this is either 4, 7, or it's 5, 6, right? Cannot have an 8, 9 there. So the last 8, 9, so one of 8, 9 has to be, cannot be here, cannot be here, and cannot be here. Well, where are the 8 and 9s in column 4? They can only be here, right? Because it can't be here because of the 8, 9 pair there. Can't be here because of the 8, 9 pair here. Therefore, the last 8 and 9 is one of these two. And it cannot be this one, because if it's this one, this adds up to 1. So this has to be an 8 or a 9. So this adds up to 17 times 2, which is 34. So these two add up to 11. So similarly, these two add up to 34. So these two add up to 11. So this is either 4, 7 or 5, 6. Which means this can't be 5. Therefore, this can't be 6. This must be 2 or 3 to add up with 8 and 9. Right? To add up to 11. This has an 8 or a 9, and then the rest, we don't know. This adds up to 17. This adds up to 17. And it's 1 through 7, right? So this cannot be 5. If this is 1, 2, 3, 5, 6, this is the 5. So this can never be 5 here. This then can't be 1, 2, or 3. And it can't be 8 or 9. It can't be 1, 2, or 3 because all of the 1, 2, and 3 has to be in this 5-cell cage. And they all see this cell. So this would be specifically not 8 or 9, not 1, 2, or 3. So this is 4 through 7. Let's see, what other ones? These two add up to 34. So this 3 adds up to 11 here. What is it? Yeah. So since this adds up to... Okay, so this adds up to 11. But this must add up to 17. So this must be 6 higher than this one, right? Than this digit. Because this is 6 greater than 11. So this, again, these two add up to 34, which is 17 times 2. Or 17 times 2, which is 34. So therefore, this must be 11 here. And we know one of these adds up to 17. So this is 17 and this is 11. The difference is 6. So this must be 6 greater than that cell because these two are the same. So this must be a 7, which makes this a 4. This can't be 4 or 7. So this must be a 1 because it must add up to, again, this is 17. Therefore, this is 10. And this adds up to 34, and this is 11. So that must be 10 plus 1. So this adds up to 10. Cannot be 1, 9, or 2, 8, or 3, 7. So this is 4, 6, which leaves these as 2 and 3. This is 4 and 6. This is 4, 7 here, which makes this 1, 2, 3, 5, 6 here. 4 has to be one of these cells here. We know also 8 and 9 cannot be both here, cannot be in this cage, and cannot be both in this cage. And 8 and 9 cannot be here, so therefore this must be an 8 or a 9 here. And one of these is 8 or 9, we're not sure which. One of these is 4. What's the minimum here right now? It's 8, 2, and 4. That adds up to 14. So then that would be 3 if that's the case, right? Can this ever be 7? You have 7 minimum, 2, and 8. That adds up to 17 already, so this cannot be 7. It could be 6, 2, 8, and 1 works. So this is 2 or 3, which means you cannot have 1, 2, and 3 here. One of the 2 or 3s has to be here. So this is specifically 2 or 3 here. We have now 1 is here, and one of 2 or 3 is here, so the rest cannot be 1, 2, or 3 here. So this is 4 through 9, but it cannot be 8 and 9 because we have a 8, 9, 8, 9 pair here. This also can't be 4 because of that 4. This can't be 5 because of this 5. So this is 6 or 7, and we know there's an 8 or 9 here. So this can never be 4 here, because that doesn't... 4 plus 6 plus 8 at minimum adds up to 18. Actually, it's... yeah, 18. So this can never be 4, which makes this a 4. The only other digit possible now, here, it cannot be 6, 7, 6, 7 with the 8, 9, because that is 6 plus 7 plus 8 at minimum, which is 21. And it can't be 2, 3 because of the 2, 3 pair in the box, and can't be 5 or 4, so it must be 1. So there must be a 1 here with 8 and 9. So this is 1, 8, and 9. Okay, so 17 is specifically 1, 9, and 7. Those are the only possibilities. So this is 1, 9. This is 7, which means this cannot be 4 and 7 here. Cannot be 4 and 7, because the 7 cannot be here. So this has to be 5, 1, 2, 3, 6, which means this is a 6, so this can't be 6 here, which means this is 1, 2, and 3. This is 2 or 3. This can't be 1, 2, or 3. This must be a 6. This can't be 5 or 6. This must be a 4. This can't be 1. This could have been 2 or 3, so that's fine. So this can't be 9 anymore. This must be 8. This is 2 and 3. So 4 plus 8 is 12, and then you have the other 2 digits adding up to 5, and therefore this must be 2 or 3. So we have a 2, 3, 2, 3 pair here. Remaining digits here, this can't be 9, so this must be 8, which makes this a 9. Remaining digit here is a 6. And the remaining digits here are 4 and 7, adding up to 10. This is 2 or 3. And the remaining digits here are 1, 5, and 7, right? So that is 13. So therefore this is 4 here, which means this 5-digit, 5-cell cage cannot add up, cannot be 1, 2, 3, 4, 7. It must be 1, 2, 3, 5, 6. So this is 1, 2, 3, 5, 6, which means one of 2 or 3 is here, and then this other one must be 7. So this can't be 7. We have a 2, 3, 7 triplet in column 4, which eliminates 2, 3, and 7 from the rest of the column. And this can't be 6 because of that 6. This can't be 2 or 3. We now have a 1, 5, 1, 5 pair in column 4, which eliminates 1, 5 from the rest of the column also. So this must be a 4. Four and 8 add up to 12, so that could be with 5. 4 and 9 add up to 13, but then this would have to be 4, but that's not allowed because we would have duplicates here then. So this has to be 4, 8, and 5 to add up to 17. That makes this a 9, which makes this an 8. This 8 makes this a 9, which makes that an 8, which makes that a 9. This 8 makes that a 9, which makes that an 8. Let's see. 5, 6. Okay, this is 4 digits adding up to 17. So the other 3 digits add up to 9. So it's either 1, 2, 6, 1, 3, 5, or 2, 3, 4. So either way, 2 out of the 1, 2, and 3s are here, and one of them's here. So the rest cannot be 1, 2, or 3. So this is 4, 5, 6, 7, but this can't be 4. These 2 digits must add up to 7. So it's either 1, 6, 2, 5, or 3, 4. And this can't be 4, so this can't be 3. And we have a 1, 2, 3. We have one digit that's either 1, 2, or 3. We have another digit that's 2 or 3. And one of these digits has to be 1, 2, or 3. So the rest of the digits cannot be 1, 2, or 3. So this is 4 through 9 also. This cannot be 8 or 9, and it can't be 1, 2, or 3. And it can't be 4, 5 because of this 4, 5, so this must be 6, 7. We know this, since this is a 9, this has to be 2. So this is 2, which means these can't be 2, which means the 3 is here in this box, which means this can't be 3, so that we have a 2, 7 pair now, which eliminates 2 and 7 from the rest of the column. So this is 3, which makes this a 2, which makes this 3, which makes these 2. Therefore, one of these 2, so that's a 1 or 2, which means this can't be 3. Since this can't be 3, this can't be 3 or 4. And this can't be 2 and 5 specifically in that order. This can't be 2, this can't be 2. Therefore, this has to have a 3. So it's either 1, 3, 5 or 2, 3, 4, because 3 cannot be in any of the rest of the cells. So it's 1 through 5. This is 1 through 5, but this can't be 4 or 5 here. This, therefore, has to be the 6, which means this cannot be 6, and this cannot be 6. This can't be 6 anymore, actually, so this can't be 5. So we have a 1, 2, 3, 4, 7 cage here. The rest of this cage has to be 1, 3, 6, and 7, which does add up to 17. This can't be 5. This can't be 5. Okay, so this is 6 or 7. This can't be 5. These can't be 6. This can't be 4. This can't be 4. One of these cages has to have an 8. The other one has to have a 9. This can't be 3, therefore it's 2. This is either 1, 6 or it's 2, 5. If this is 1, 6, this would have to be 7, which would make that 3, which would make that 2. And then this would have to be 4 with it, because 2 cannot be with 5 here. So let's go through that. Okay, this can't be 7 either. So again, if this is 1, 6... Wait, hold up. Yeah, if this is 1, 6... Oh, I messed up. I was like, this doesn't add up. It's not 6. Ugh. Okay. Let's go back. It's 1 and 7. My apologies. But it's still very similar. Okay, so still this is the same. This is not 3 and 4. This is 3 and 5. So these can be 7. So it's 1... No, hold up. I was right. This is... No, that's correct. That's correct. Yeah, no, I was correct. Sorry. I kept seeing this, and for some reason I kept equating the 1 and 7 there. Wait, no, that's right. That is correct. Sorry. This isn't... Yeah, so I was incorrect here. Apologies. This is 9, so this must be 8. These two digits must add to 8. So it's 1, 7, 2, 6, and 3, 5. This can't be 7, so this can't be 1. And again, similarly, this must contain a 1, 2, or 3. This is 2 or 3, and that's a 1, 2, or 3. So there cannot be a 1, 2, or 3 in the remaining cells. This has to be a 2 still, because of these add up to 11. So the rest of this can't be 2. So apologies, this was basically, instead of being adding up to 7, it's supposed to add up to 8, because this is 17, and then 9, 17 minus 9 is 8. Let's make sure we got this right. 9, yeah, this is 1, 2, 6, 1, 3, 5, or 2, 3, 2, 3, 4. So this cannot be 3, which makes this a 2, 7 pair, which makes that a 3, which makes this a 2, which makes that 3. Therefore, these can't be 3. It's a 1, 2 pair, which eliminates 2 here. This is 3, so this cannot be 3 and 5. So this is 1 and 7 or 2 and 6. Okay, that makes things much better. Therefore, this is 6 or 7 also, because it cannot be 1, 2, or 3, because one of these is 1 or 2, and this can't be 2, so this can't be 6. One of these is 1 or 2. One of these is 1 or 2, so 1 and 2 is ruled out. 3 is ruled out here. 4 and 5 is ruled out here, and 8 and 9 are ruled out, so it's only 6 and 7. Well, we have a 6-7 pair here now. One of these has to be 6 or 7, and this has to be 6 or 7, which eliminates 6 and 7 from the rest of the row and from the rest of the box. So this can't be 6 or 7. This can't be 7, so this becomes 4, which makes that a 7. These can't be 4, so it's a 5, 8, and 9 triplet here. This can no longer be 7 here, and it can't be 5. So this has to then be 6 and 4 here. This cannot be 4, 6, or 7. It can't be 5. Therefore, it's a 1, 2, 3 triplet here. I don't know why I removed the 7. It can't be 5 or 6. This actually has to have a 7 here. And this can't be 5 or 6 here. Well, whereas the 4 in this column 1, it has to be here. So this is a 4. This can't be 7 because of the 6-7 pair here. Where's the 5? It has to belong to the cage. So then if you have a 5 in the cage, that means 5 plus 8 adds up to 13. 17 minus 13 is 4, and only 1 and 3 can be here. So this has to be 1, 3, and this is 1, 3, and 5, but this can't be 5. So where's the 5 in column 2? It must be here. Since we have a 1, 3, 1, 3 pair in the column, this can't be 1, so this is 2, which makes this a 1. This can't be 2. So the 2 has to be one of these, which we kind of knew. We have a 1, 3, 5, 6 quadruple in row 6, which eliminates 1, 3, 5, and 6 in the rest of the row. Therefore, this can't be 1 or 3. This can't be 6, so that makes this a 4. This can't be 5, so that's 8 and 9. This 4 can't be a 4, so this must be a 6. Yeah, and the reason why we could eliminate 5, 8, and 9 is we had a 5, 8, 9 triplet in box 4. That's the reason. The rest of this row has to be 2, 7 with 8, 2, 7, 8, and 9. Because there's no 1, 3, 5, 6, there's no 4 here. So 6 has to be one of these two, so this can't be 6. 5 has to be one of these 3, because this can't be 5, and there's no other 5 possible anywhere else, so this can't be 5. This can't be 5. Well, we can't have a 5 here because of that, too. The rest of this is 1, 3, 6, and 7. This can't be 7. We now have a 1, 3, 6 triplet in row 7, which eliminates 1, 3, and 6 in the rest of the row. So this can't be 1, 3, or 6, or 2, so this has to be a 5, which means none of these can be 5. What else are we missing? 2 can't be here, 2 can't be here. Where is the 2 possible? It has to be here in box 7. So this has to be 2, which makes this a 6, which makes this 7. This 6 means this can't be 6, and this can't be 7 here. We know the 2 can't be here anymore, and this can't be 8. This can't be 7. These can't be 6. Okay, this can't be 3, therefore it's 2. What do these add up to? One of these is 8 or 9. That means the other 8 or 9 cannot be here, but it could be any of these. In fact, it has to be one of these 3. So if you have 2 and 8, this would have to be 7, so this can't be 2 and 8. If this is 2 and 9, you have to have a 6 here, but it can't be 6 either. So if this is 2, 8, this has to be 7, but that's not allowed because of that 7. So this can never be a 2. If this was a 2, again, if this is 2 and 8, if the 2 is here specifically, and this is with 8, this would have to be 7, but that's not allowed. If this is 2 and 9, this would have to be 6, and that's not allowed. So 2 can never be here, which means this is a 7, which makes this a 2. None of these can be 2. This is 7 either it's 8 and 2, which would add up to 17, or it's 9 and 1. And it cannot be 9 and 1, so this must be 2 and 8. Which means this can't be 2, which forces this to be 2. Now we have a 1, 3, 1, 3 pair in row 9, which eliminates 1 and 3 from the rest of the row, so this must be a 6. Because it can't be 1 or 3. And therefore this can't be 6. This can't be 8, so this is 9, which means this can't be 9. This can't be 2 because of this 2, so this must be 7, which makes that a 2. 7 cannot be here, whereas the 7 possible, it has to be here. And the remaining digits here have to be 3, 5, and 9. Well, 5 can't be either of these, so this must be 5, which makes this an 8, which makes that a 5. This 8 makes that a 9, which makes that an 8. This can't be 9 anymore, so this must be 3, which makes this a 9. This can't be 1 or 3 anymore. This can't be 9, so this is 1, which makes that a 9. This can't be 1 or 3, so this is a 6. Where is the 6 in column 5? It has to be here now. So this is 6. One of these is a 5. We need to see which ones are which. So this we're going to make green. This will make red. So this one has to be the red because it's not the green one. Therefore, this is green. This can't be green, so this is red, which makes that a green. This is also a green. So green cannot be here or here, therefore can only be here, which means green is the 1. So this is 1. The red has to be here because it's the only other possibility, and this has to be red. So one of these is red. That's fine. So all the reds are 3s. That's 3 in the corner. We celebrate because we know we're close to solving this. This has to be a 5 because it can't be 1 or 3. This has to be 7, which makes this a 1, which makes that a 5. This can't be 1 or 3, so this must be a 7. And that's how you solve it. Apologies about this cage here. I don't know why. It got into my head that it had to add up to 7 when it's actually has to add up to 8. Fortunately, I was able to spot it fairly soon after I made the mistake, which is good. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.